Picture this. It's a summer day in 1950, Los Alamos, New Mexico. A group of scientists is walking to lunch at the Fuller Lodge. They're some of the brightest minds in the world, physicists who helped build the atomic bomb, men who understand the deepest secrets of the universe. One of them is Enrico Fermi, an Italian-American physicist, Nobel Prize winner, one of the architects of the nuclear age, a man known for his ability to make quick, accurate calculations about almost anything. The scientists are chatting casually. The topic turns to a recent New Yorker cartoon about aliens. They joke about UFO sightings, about flying saucers, about little green men. It's lighthearted, playful. But then in the middle of lunch, Fermi suddenly looks up from his food. His expression changes. He's not joking anymore. He asks a simple question, almost to himself. Where is everybody? His colleagues are confused. What do you mean? Who? Fermi explains. The universe is vast. Billions of stars in our galaxy alone. Billions of galaxies in the universe. Many of those stars have planets. Some of those planets must be like Earth. Life must have evolved on some of them. Intelligent life. Civilizations. Some of those civilizations must be millions of years older than us. They should have developed technology. Space travel. They should have colonized the galaxy by now. So where are they? Why haven't we seen them? Why haven't they visited us? Why is there no evidence of their existence? The question hangs in the air. No one has a good answer. This is the Fermi paradox, one of the greatest mysteries in science. The contradiction between the high probability that intelligent life exists elsewhere in the universe and the complete lack of evidence for it. 2 trillion galaxies in the observable universe, each galaxy containing hundreds of billions of stars, countless planets, billions of years for life to evolve, and yet silence, no signals, no visitors, no evidence of anyone out there. Where is everybody? This is the question we're going to explore. The Fermi paradox, why we should expect the universe to be teeming with life, but find nothing, the possible explanations, the theories that try to answer Fermi's question, and what it all means for humanity's place in the cosmos. Let me take you on a journey through the universe, through the numbers, through the silence, and through the possible answers to the greatest question we've ever asked: are we alone? To understand the Fermi paradox, you first need to understand just how big the universe is, and the numbers are almost impossible to comprehend. Let's start with our own galaxy, the Milky Way. It's a spiral galaxy, about 100,000 light-years across. That means if you could travel at the speed of light, which is about 186,000 miles per second, it would take you 100,000 years to cross from one side to the other. The Milky Way contains somewhere between 100 billion and 400 billion stars. Let's use 200 billion as a rough estimate. That's 200 billion stars, each one a sun, many with their own planets. Now, recent discoveries have shown that planets are incredibly common. Almost every star has at least one planet. Many have multiple planets. Scientists estimate there are at least as many planets in the Milky Way as there are stars. So let's say 200 billion planets in our galaxy. Of those 200 billion planets, how many could support life? We're looking for planets in the habitable zone, sometimes called the Goldilocks zone, not too hot, not too cold, where liquid water can exist. Based on data from telescopes like Kepler and TESS, scientists estimate that about 20% of stars have an Earth-like planet in their habitable zone. 20% of 200 billion is 40 billion. 40 billion potentially habitable planets in our galaxy alone. But wait, the Milky Way is just one galaxy. How many galaxies are there in the observable universe? 2 trillion. That's 2 trillion galaxies. If each galaxy has, say, 100 billion stars, and 20% of those stars have habitable planets, then the number of potentially habitable planets in the universe is astronomical. We're talking about billions of trillions, a number so large it's meaningless. And the universe is old, very old, about 13.8 billion years old. Earth is about 4.5 billion years old. Life appeared on Earth relatively quickly, within the first billion years. If the same thing happened on other planets, there could be civilizations out there that are millions or even billions of years older than us. Think about that. Human civilization is maybe 10,000 years old. We invented radio a little over 100 years ago. We went to the moon about 50 years ago. Imagine a civilization that's been around for 1 million years, 10 million years, 1 billion years. What would their technology be like? They would seem like gods to us. Given these numbers, intelligent life should be common in the universe. Civilizations should be everywhere. They should have colonized the galaxy. They should be sending out signals. We should see evidence of them. But we don't. Nothing. Silence. This is the paradox. In 1961, astronomer Frank Drake tried to quantify the question. He developed what's now called the Drake equation, a formula to estimate the number of active communicative extraterrestrial civilizations in the Milky Way. The equation looks like this. Henu rug goas, FP goas, Eno was fud, what goas, FP goas, FC goas, L goas, L goas, FC goas, L goas. Let me break it down. Heme is the number of civilizations we could potentially communicate with. Rod asterisk is the rate of star formation in the galaxy. How many new stars are born each year? FP is the fraction of those stars that have planets. Niche is the number of planets per star that could support life. FL is the fraction of those planets where life actually develops. FIS is the fraction of life-bearing planets where intelligent life evolves. FC is the fraction of intelligent civilizations that develop technology to send signals into space. LUBI is the length of time those civilizations send signals, how long they survive. Some of these values we know fairly well. Star formation rate about 1-3 new stars per year in the Milky Way. Fraction with planets close to 100%. Number of habitable planets per star, somewhere between 0.1 and 0.5. But some values we have no idea. What fraction of habitable planets develop life? We only know of one example, Earth. Is life common, arising wherever conditions are right, or is it incredibly rare, a 1 in a billion fluke? And what about intelligent life? Life existed on Earth for over 3 billion years before anything resembling intelligence appeared. Is intelligence an inevitable outcome of evolution, or is it a rare accident? And how long do civilizations last? Humans have had radio technology for about 100 years. Will we last another 100 years? 1,000? 1,000,000? Or will we destroy ourselves? Depending on the values you put into the Drake equation, you can get wildly different answers. Optimistic estimates suggest there could be millions of civilizations in our galaxy. Pessimistic estimates suggest we might be the only one. The equation doesn't solve the Fermi paradox, but it helps us understand the variables, and it shows just how much we don't know. Given the vastness of the universe and the high probability of life, why haven't we found any evidence of extraterrestrial intelligence? Over the years, scientists, philosophers, and thinkers have proposed many possible explanations. Some are hopeful, some are terrifying, all are fascinating. Let's explore the main theories. One explanation is that intelligent life is incredibly rare. Perhaps the conditions needed for life to arise are so specific, so unlikely, that Earth is one of the only places it happened. This is called the rare Earth hypothesis. It suggests that while simple life might be common, complex intelligent life requires a very specific set of circumstances. Earth has a lot of things going for it. A stable sun that's not too hot or too cold, a position in the habitable zone, a large moon that stabilizes our axis and creates tides, a magnetic field that protects us from solar radiation, plate tectonics that recycle carbon and regulate temperature, a giant planet Jupiter that acts as a cosmic vacuum cleaner, absorbing asteroids that might otherwise hit us. Maybe all of these factors are necessary for intelligent life to evolve, and maybe having all of them is extremely rare, 1 in a billion, 1 in a trillion. If so, intelligent life might be so rare that we're the only example in the entire observable universe. We're not just rare, we're unique. Another explanation is the Great Filter. This is perhaps the most unsettling theory. The idea is that somewhere between lifeless matter and an advanced spacefaring civilization, there's a barrier, a filter, something that prevents life from progressing. Maybe the filter is the origin of life. Maybe getting from non-living chemistry to the first living cell is almost impossible. If so, the filter is behind us. We've already passed it. We're the lucky ones. But maybe the filter is ahead of us. Maybe civilizations tend to destroy themselves before they can colonize the galaxy. Nuclear war, climate change, artificial intelligence gone wrong, engineered pandemics. Maybe every civilization reaches a certain point and then self-destructs. If the Great Filter is behind us, that's good news. It means we've passed the hardest part. The universe is empty because life is rare, but we made it. If the Great Filter is ahead of us, that's terrifying. It means something is going to destroy us, and we have no idea what it is. When we look for evidence of alien civilizations and find nothing, we should hope the filter is behind us, because if it's not, our days may be numbered. A more optimistic theory is the zoo hypothesis. This suggests that intelligent alien civilizations exist and know about us, but they're deliberately avoiding contact. Why? Maybe they're observing us, like scientists observing animals in a nature reserve. They don't want to interfere with our natural development. They're waiting for us to reach a certain level of maturity before making contact. Think of it like Star Trek's Prime Directive. Don't interfere with pre-warp civilizations. Let them develop on their own. Under this hypothesis, Earth is essentially a nature preserve. Aliens are watching, studying, but not interacting. Maybe they'll contact us when we're ready, when we've proven we can handle it, when we've stopped fighting each other and learned to live sustainably. It's a comforting thought. We're not alone. We're just being given space to grow. A darker version of the zoo hypothesis is the dark forest theory. This comes from Chinese science fiction author Liu Cixin's novel The Dark Forest. The idea is that the universe is like a dark forest. Every civilization is a hunter with a gun, creeping through the trees. If you see another hunter, what do? Do you call out and try to make friends? That's risky. They might shoot you. Even if they seem friendly, they might be pretending. Or they might have friends who aren't friendly. The safest strategy is silence. Stay hidden, don't make noise, and if you see someone else, shoot first. Don't take the chance. Under this theory, intelligent civilizations are everywhere, but they're all hiding. They're afraid to reveal themselves because the universe is dangerous. Any signal you send might attract a predator, so everyone stays quiet. This would explain the silence. Everyone's there, but everyone's hiding. It also suggests we should be careful. Humanity has been broadcasting radio signals for over a century. We've sent messages intentionally, like the Arecibo message. We're not being quiet. In the dark forest, we're standing in a clearing, shouting and waving our arms. Maybe that's not a good idea. Another possibility is that they're already here, and we just don't recognize them. Their technology might be so advanced that we can't perceive it, like ants not recognizing a highway or a skyscraper as artificial constructs. Or maybe they exist in forms we don't expect, not biological beings but artificial intelligence, not on planets but in the spaces between stars, not communicating with radio waves but with something we haven't discovered yet. We're looking for aliens that are like us, biological planet-dwelling, communicating with electromagnetic signals, but maybe that's incredibly narrow-minded. Maybe aliens are so different that we wouldn't recognize them even if they were right in front of us. A simple explanation is that space is just too big. Even if civilizations exist, the distances are so vast that contact is impossible. The nearest star to Earth, Proxima Centauri, is about 4.2 light-years away. With current technology, it would take us tens of thousands of years to get there. Even a signal traveling at the speed of light takes 4.2 years. If civilizations are scattered across the galaxy, they might be so far apart that they never encounter each other. Ships can't travel fast enough. Signals take too long. The universe is big and we're all islands, isolated by the void. Some theorists suggest that civilizations don't stay in a communicative phase for long. They develop technology, broadcast signals for a few hundred years, and then either destroy themselves or advance to technology we can't detect. Think about humanity. We've been broadcasting radio signals for about 100 years, but we're already moving toward fiber optics, targeted communications and other technologies that don't leak signals into space. In another 100 years, Earth might be radio quiet. If civilizations typically broadcast for only a few hundred years out of their millions of years of existence, the window for detection is tiny. We might just be missing each other. The Fermi paradox isn't just theoretical. We've actually been looking for evidence of extraterrestrial intelligence, and the silence is real. SETI, the search for extraterrestrial intelligence, has been scanning the skies for over 60 years. Using radio telescopes, they've listened to millions of stars, searching for signals that might indicate intelligent origin. The results? Almost nothing. There have been a few tantalizing hints. The most famous is the WOW signal. On August 15, 1977, astronomer Jerry Eman was reviewing data from Ohio State University's Big Ear radio telescope. He saw a signal that was strong, narrow band, and came from the direction of the constellation Sagittarius. It lasted 72 seconds. It matched what scientists expected an extraterrestrial signal to look like. Eman circled it on the printout and wrote "WOW" in the margin. The signal has never been explained. It wasn't from Earth. It wasn't from a satellite. It wasn't a known natural phenomenon. But it also never repeated. Scientists have pointed telescopes at that spot in the sky many times since, and there's been nothing. Was it a message from an alien civilization, a natural phenomenon we don't understand, a glitch? We don't know. And after nearly 50 years, we may never know. In recent years, a new term has entered the conversation: UAP, unidentified aerial phenomena, what most people call UFOs. For decades, governments dismissed UFO sightings as misidentifications, hoaxes, or delusions. But in 2017, videos from U.S. Navy pilots were leaked to the public. They showed objects performing maneuvers that seemed to defy physics, speeds and accelerations beyond any known technology. No visible means of propulsion. The Pentagon confirmed the videos were authentic. They established a task force to investigate UAPs. In 2021 and 2022, they released reports acknowledging that some sightings remain unexplained. This doesn't mean aliens are visiting Earth. The objects could be advanced foreign technology, atmospheric phenomena, or sensor glitches. But for the first time, the US government is taking the question seriously. They're admitting they don't know what these things are. It's not proof of aliens, but it's a crack in the door. In 2017, astronomers detected something they'd never seen before, an object from outside our solar system passing through. They named it Oumuamua, Hawaiian for scout or messenger from afar. It was the first known interstellar object. But Oumuamua was strange. It was shaped like a cigar or a pancake, not like typical asteroids or comets. It showed no signs of outgassing, no tail, no coma, and as it passed the sun, it accelerated in a way that couldn't be explained by gravity alone. Most scientists believe it was a natural object, perhaps a chunk of nitrogen ice, or a fragment of a disrupted planet. But Harvard astronomer Avi Loeb suggested it might be artificial, an alien probe, a piece of technology, a solar sail perhaps, pushed by sunlight. The idea was controversial. Most astronomers disagreed, but it raised the question: if an alien probe did enter our solar system, would we recognize it? We're getting closer to answering Fermi's question. New tools and technologies are expanding our ability to search. The James Webb Space Telescope, launched in 2021, can analyze the atmospheres of exoplanets. It can look for biosignatures, chemicals like oxygen, methane or phosphine that might indicate life. Within years we might detect signs of life on other worlds. The Perseverance rover is currently on Mars, collecting rock samples that will be returned to Earth in the 2030s. Scientists will analyze them for signs of past life. If Mars once had life, it would prove that life can arise independently on multiple worlds. New radio telescopes like the Square Kilometre Array will be orders of magnitude more sensitive than current instruments. If there are signals out there, we'll have a better chance of finding them. And the search for technosignatures is expanding beyond radio waves. Scientists are looking for laser signals, megastructures, heat signatures, anything that might indicate technological activity. We're looking harder than ever, and the universe is slowly giving up its secrets. So where is everybody? After all these theories and all this searching, we still don't know. The Fermi paradox remains unsolved. Maybe we're alone, maybe life is rare, intelligence is rarer, and we're the only ones who made it, a single candle in an infinite darkness. Maybe they're out there but we haven't found them yet. Space is big, time is long, maybe we just need to keep looking. Maybe they're hiding, the universe is dangerous and everyone stays quiet to survive. Maybe we should be more careful. Maybe they're watching, waiting for us to grow up, waiting for us to prove we're worthy of contact. Or maybe the answer is something we haven't thought of yet, something beyond our current understanding, something that will make us rethink everything we know about life, intelligence, and the universe. The search continues. Every day scientists point telescopes at the sky, analyze data, listen for signals. They're looking for the answer to Fermi's question. And one day maybe we'll find it. Enrico Fermi's question, asked casually over lunch in 1950, has become one of the defining mysteries of our time. 2 trillion galaxies, hundreds of billions of stars in each one, billions of potentially habitable planets, billions of years for life to evolve. The numbers say life should be everywhere. But when we look, we find nothing. No signals, no visitors, no evidence. Where is everybody? Maybe they're rare, maybe they're hiding, maybe they're watching, maybe they destroyed themselves, maybe we're the first, maybe we're the last. We don't know, and that uncertainty is both terrifying and beautiful. We're asking the biggest question possible: are we alone in the universe? And we're actually trying to answer it, with science, with technology, with curiosity. Whatever the answer, it will change everything. If we're alone, we're precious beyond measure, the only minds in an infinite cosmos. We have a responsibility to survive, to spread, to carry the torch of consciousness. If we're not alone, then contact will transform humanity. We'll learn we're part of a larger community. We'll gain knowledge, perspective, perhaps wisdom. Either way, we need to know. We need to keep asking. We need to keep searching. Where is everybody? 75 years after Fermi asked the question, we're still looking for the answer, and maybe, just maybe, we're getting closer. The universe is vast, ancient, and silent, but we're listening, and one day we might hear something. Until then, the question remains, the paradox endures, and the search continues. Where is everybody?